There is quite a lot going on in this problem if you look at it initially, so let's kind of take this step by step and stay with me. Please hit pause as we go through these videos and try to think through some of the things on your own. And then once you're kind of at that stuck point, you're not sure what to do next, that's when you hit play and hear me continue on. Let's read problem first. What volume of chlorine gas, which we know chlorine gas is Cl2 because chlorine is diatomic, it's at 38 degrees Celsius. Remember, we're not going to leave anything in degrees Celsius. We're going to go ahead and convert that into 311 Kelvin. Here we have a pressure of 1.63 atm. And then we're given a value of sodium chloride. And that's 10.4 grams. And yeah, so here's the situation where we're going from liters of chlorine gas is what they're asking us for, but we're given 10.4 grams. And hopefully right off the bat you see that this is a non-STP problem. What we've been doing is taking the chemical reaction and using a gas Stoich problem, but in this situation we can't do that because it's not at STP, so we can't use 22.4. So we're going to have to kind of find another way to get there. Second thing to look at is that there's no balanced chemical reaction, but guys, this is an easy one. We know that sodium chloride is being formed. We see that chlorine gas. So let's go ahead and take sodium plus Cl2. We know it's chlorine gas yields NaCl. And let's just go through and balance it with two coefficients, and we're ready. Go ahead and write down that given information. We know that we have 10.4 grams of, that is 10.4 grams of sodium. Here we go. And I'm just going to kind of come up here and write down everything else. We're looking currently for volume, and keep in mind we're looking for volume of chlorine gas because that's important here. And it told me that the temperature is 311 Kelvin. The pressure is 1.63 atm. We know that R is a constant. And then, of course, if we could find N, then what could we use here? Ideal gas law. Okay, but once again, look at the value you're given. You're given 10.4 grams of sodium, and we would need moles of chlorine to do that. So think back to stoichiometry. No, you don't want to, but let's do it. Can you go from 10.4 grams of sodium and turn that into moles of chlorine? And you absolutely can. Let's go ahead and drop down grams of sodium. And at this point, we know that 23 grams of sodium represents 1 mole of sodium. And then we're going to drop down moles of sodium again. And here's where we see that mole to mole ratio. So we're going to plug in our coefficients here. And when we multiply straight across and then divide, we get 0.226 moles of chlorine. And that is important because now that I'm in moles of chlorine, I can plug it in up here to my ideal gas law. So, pressure 1.63, and again that's atm, times volume, I'm not sure, that's what I'm looking for. I've got 0.266 moles, and notice that that's chlorine times universal gas constant is R. So think, are you going to use that 8.31 or that 0.0821? We're going to go with 0.0821 because notice that the pressure is given to us in atm, so we can just leave it like that. And then temperature 311 Kelvin. And now we are just going to do a simple algebra problem to solve for volume. And we would end up with 4.17, and notice that that is in liters. I know that these, again, can look big and scary, but they're not. We're taking a gas Stoich problem, which is really just a Stoich problem, and converting it into moles of chlorine, and then we're taking that value and plugging it back up here into our ideal gas law.